So what about if we add a pulley into the system? And we know what pulley does. Basically, it's just transferring the force from one direction to another direction. So if you have, let's say, a system like this, and there's a pulley here, and there's a mass MA, and there's another mass MB. If I consider this as a system, the tension here and the weight of the B are the forces acting on this, but then this rope will move around the pulley, and this pulley basically doesn't have any mass. We assume it's massless, so it's just changing the direction of force of tension without affecting the value of it. So here is becoming the same tension, and then for A become MAG. And you could also consider the whole thing as a system. So basically the tension becomes the internal force if MB is bigger. So you can say MBG minus MAG is MA plus MB times A. That gives you the acceleration of the system, because tension is internal force if you consider both the same as one force. But this is based on the ground that pulley and the rope doesn't have any mass. This can have different also type of design, like in, or maybe I draw another one here, and then here comes, and then here A, B, C, and you can see, for example, M, A, G, and then this is T, and then here the T acting on B, but then because his has a mass, part of the force is to move to change the inertia of the B, because inertia is property of the mass that doesn't want to change its position, doesn't want to follow the acceleration, so it absorbs unless you act as a force on it. So it takes part of T to move, and then the rest of it is T prime, and then here is T prime, and then this is MCG. Assuming there is a directional motion like this, so this is a frictional force between the surface and the mass B. So you can write the equation of motion in AG. If you consider the whole thing as a system, therefore MAG is this mass, this friction is our external force, but the tension becomes internal force. So MAG minus FB plus MCG is equal to MA plus MB plus MC times A. But you can also consider A as the system, so you could say MAG minus T is MAA. You can consider B as the system. This is A, this is B, so T minus T prime plus FB is MBA. Or you could consider C as the system, so T prime minus MCG is MCA. This is A, B, and C. And the, The system can be also, let's say, for example, inclined plane like this with different slope. One theta 1, this one theta 2, and then the pulley is here. Then you have the mass in a, let's say this is B, B. So this is MBG sine theta and MBG cosine theta and MB. There is a force of tension here which transfers through the pulley. So this pull off, it transfers here without changing the magnitude to A. So if this is the system, this one also MAG sine theta and MAG cosine theta. If I consider the whole thing, you could also have, let's say this is the direction of motion. So there is a force FA, FB. As a frictional force on the surfaces. So MAG sine theta minus FA plus FB plus MBG sine theta is equal to MA plus MB times A. This is A and B. Right? If it is A system, then is MAG sine theta minus T is MA. If it is B, then T minus MAG sine theta. Sorry, here I forgot to put the frictional force FA for the case that A is the system. So MA sine theta is this force minus 2 opposing force, which is T plus FA is equal to here. This is when the A is system, MA, A. And then if B is the system, T minus MA, MB, G sine theta plus FB is